This video demonstrates the methods of traffic signal optimization. For this example, we'll apply corridor optimization, which is based on simulation output on nodes 1 and 2 together. So the idea is that our current scenario for the PM peak hour is using 2040 forecast volumes as the demand input, and to this point the signal plans we've implemented reflect the existing year signal timing. So effectively we are optimizing these signal timings as a way of reasonably estimating the future year signal timings before we actually run simulations and collect output and estimate level of service for the future year. So we'll go to the input file section and under signals, select choose or create, and we'll make a copy of this file and name it optimize signal timing. And this will serve as our new input for this scenario. And the idea is that when we optimize the signal timings in the next steps here, this is the file that's being modified. So we want to keep a backup copy of that existing timing plan in case we want to start over this process. But this will be our new working file. And to run the corridor optimization, superlinks should be defined and the simulation should be free of errors. We're assuming that's already been done, and we'll select a corridor with a pair of waypoints. This represents the path that's being favored or optimized based on the results here. So we want to select the next adjacent node upstream from the first intersection, and then just move the cursor over to the next node that's adjacent downstream from the last node that we're optimizing. So in this case, it's fairly simple. We have just two intersections, so we're choosing first the node to the left and second the node to the right. And we'll double click and select confirm this is what we want. And by doing so, these options are now enabled, so we can select optimize the corridor. So at the top here we see 5 o'clock to 6 o'clock represents the whole simulation period, but we can shorten this. This will be based on the peak 15 minutes and then one additional 15-minute period to make sure we're addressing all the residual traffic in the next period. We have the option of optimizing for either both directions or just a single direction. If you choose one direction, this is based on the indicated direction of the waypoints we've selected. So in this case, we started here and then ended it at this boundary node. So this would be an eastbound based optimization, but we'll choose both directions. And then similarly, just as in the single intersection method, we can either choose to update the cycle length based on a range we decide, or base it on the assumption of a fixed cycle length, in which also we can keep the same one we have or just select a whole new one. So we'll do the same thing as the other method. We'll allow a range of 100 to 140 and then 10-second steps. The performance index MOE weights is what the optimization results are ultimately based on. So this allows us to just set a higher priority or a higher weight on any of these metrics. So if we decide that arrival on green is the most important thing we want to maximize, or we want to minimize queue length, this is the most important thing maybe, we can also change that. So we'll call this 5 and leave the rest at their default values. The master intersection is a way of locking the existing offset of this intersection, if that's the one we're choosing. On the Offsets tab, there is a short explanation of the two-stage offset optimization process. The first stage evaluates offsets in larger step sizes. Some cycle lengths may be eliminated after the first stage. The second stage refines the offsets. The values in the Offset tab can be edited by the user. Now we can go ahead and choose Start. Multiple engines will launch to run simultaneous simulations. You will see a row for each cycle length to be evaluated. The row highlighted in green is the last completed evaluation, and the PI in yellow is the current optimum. The stage column tells you whether you are in the first or second stage of offset optimization. You can see how many simulations have been completed, as well as the estimate for how long before completion. Okay, so when the results have been compiled, the optimization is done running. We've determined that the best cycle length is 100 seconds based on these results, and these are new offsets that will be assigned to those two intersections we've chosen. And we can either choose to simply save this as our new signal timing plan, or we can choose manually if we decided in the middle of the simulation that we changed our mind and we want to use different weights, and we wanted to prioritize, for example, arrival on green more than queue length, then the performance index in the table here will automatically update based on any new inputs we provide here. So in this case, if we change the priority of arrival on green, then 120 seconds would be actually the best. So go back to the original weights we had, and we can then choose to save the timings, which will update whichever signal timing file is the current selected input in our project settings. Or if we forgot to create a backup copy, as we showed in the first step of this topic, we also have the option to select Save Timings As, and if we wanted to, we could create a new file to establish the new optimized timings here. So we'll go ahead and just choose Save Timings.